Hello everyone, I'm Chris Mackey, the co-founder of Ladybug Tools LLC, and today I'm going to be talking to you about eliminating the redrawing from scratch problem in BIM to BEM. And to give you a brief introduction to Ladybug Tools LLC, we produce two main types of software, one of which is our open source Ladybug Tools project, which has been going on for a decade or so, and the other is a set of commercial products that we've recently started selling around this open source core library. And we sell these products under the banner of pollination, and they include a Rhino and Revit plugin that you'll hear me reference throughout this presentation. But all of our commercial products and most of our open source projects are aimed at tackling the same problem in the industry, which I like to refer to as the 2-week turnaround problem. And many of us are likely familiar with this problem where you will have a kickoff meeting with both the design team and the energy modeling team. These two parties will go their separate ways after that kickoff meeting. The design team will work on developing their design option, and somewhere near the end of one of the phases, there will be a big Revit model or set of 2D drawings sent over to the energy modeling team. They'll get back to the design team, and they will spend a full week or two often retracing the model from scratch in the building energy modeling platform that they are using, such that by the time they've run the study and they've sent the results over to the design team in a PDF report, so much time has passed without feedback that the design has completely changed, and the team says, "Thank you very much. I don't know how relevant your findings are given so much has changed since we sent you that first model." And so this is a very big problem in that not only are we consuming a lot of time in the energy modeling process, but we're also not making the full use of the capability of energy modeling to make our designs better and our buildings better. This is why we're trying to solve this problem, and by a long shot, the biggest sink of time in this whole process right now is this redrawing the model from scratch in the building energy modeling interface. To explain briefly why this problem exists, I should note that people have been trying to solve this for at least a decade or two so far. It's for this reason that we have file formats like GBXML that are meant to be a schema that different platforms can import and export to. But if you guys have ever used the GBXML importer that is built natively into Revit, you know that you end up with something that requires a lot of manual cleanup. You see an example of this here. We have open room volumes, missing surfaces, such that a lot of modelers end up looking at this and they say it is just going to be faster for me to retrace all the geometry from scratch in my building energy modeling platform. So we're trying to avoid this, and the way that we do this is that we offer a Revit plugin that can take that Revit model and export a file format that we've developed called HBJSON, which is similar in principle to GBXML. It is open source, and the schema is available online so anybody can look at it. But importantly, we've written a series of translators around the HBJSON such that people can take their models from Revit or Rhino and export to a variety of different energy modeling file formats. So you can get a very clean GBXML by using our plugin and our export pathway through this workflow. Similarly, we're trying to solve the problem at the other end as well. So you may have a very detailed GBXML like this model of the Sydney Opera House here. But if you were to try to import this GBXML into a software like IES for energy modeling, this is what you'd get, where all the rooms get reduced to simple extrusions, even though the model was valid and simulatable to start off with. So what you can do is that you can import a file like that GBXML to our Rhino plugin. That will convert it to an HBJSON format, and then you can save that HBJSON to a .gem file, which is the native geometry specification of ISVE, and you'd be able to open that file in all of its beautiful geometric detail in the ISVE platform. So at this point, you probably realize HBJSON, this file format, is a linchpin that makes all of this work. But importantly, it's not just the file format that we've written and the Rhino plugin, which is a kind of interface for importing, exporting, editing, and validating your HBJSON models. It's also the fact that we worked on all these translators from these different file formats into all these formats. And that's how you'd be able to take a very detailed model like the Sydney Opera House, and if you build it within our software or import it into our software, you'd be able to save it to all these other energy modeling formats, whether it's Design Builder, eQuest, ISVE, iDice, OpenStudio, etc. And not only is it the file format and the translators that we've written here, but we've also included a validation routine and gives you a full list of everything that is invalid or wrong about your model so that you can fix that and know if there's anything that's going to prevent you from saving your model to any of these other energy modeling formats. And you can see we have an interface for that validation routine. This is in our Rhino plugin that lets you zoom into everything, each and everything that's wrong about your model so that you can then fix it. In addition to just having the validator, right, that tells you everything that's wrong, we also have a lot of automated commands to clean up and fix your model. And just to give you a very common one of those that we built into our plugins and software, this is a typical export of a hospital floor from our Revit plugin. And you can see it has all these little jogs and holes in it as a result of all these room bounding columns. And we have a routine that can essentially generate a bunch of alignment lines from the axes that it senses within your model. And we have another routine that will snap all the rooms to this grid, to these generated alignment lines, such that you can go from this to this in a matter of minutes. And this is how we have users like that, which you see here, which built a model with over 2,000 zones. And he was able to do this in 7 to 8 hours. He thinks he could do it even faster because this was the very first time he was using our tools. And we have many, many companies using our pollination products in their workflows to eliminate the redrawing from scratch problem. And so to wrap up the presentation here, I'm very excited to announce we have one new exporter in our plugins and in our core libraries, and that is that you can now save your models that you build with our software as the CBEC Standards Data Dictionary format. And so if you were to go to this link on our forum here, you'll see a full page that describes this. You're able to save your files as a CBEC Standards Data Dictionary. You can open up that XML file within CBEC and get a full list of all your rooms with the geometry ready to be processed for code compliance in California. So with that, thank you so much for listening and enjoy the rest of the conference.